You should turn some around. Okay, so we've got 8 over 3 minus 12 over 3, so that would be negative 4 over 3. Now, as I said, we were expecting it to be negative because it's underneath the x-axis. However, when we give our answer, they would expect you, or if they're asking what the area is, you would then just say the area is 4/3. Because an area wouldn't be a negative value, it's just a negative answer because it's underneath the x-axis. Does that make sense?
Mm-hmm.
Okay, so the area itself is just 4/3. Yeah?
Yeah.
Yeah. Okay. Now, that's all well and good if what they've asked us to find is completely underneath the x-axis. The issue arises is for questions like this. So here we've got the same function, x squared minus 2x. But in this case, they want the area between 1 and negative 1. Now, here we can see that some of it is underneath, some of it is on top. So if we were to just do what we've done and have x cubed over 3 minus x squared, that's what it ended up as, wasn't it? And we just stuck these numbers in, what's going to happen is that this negative value is going to cut out a portion of the positive value. And so what we would end up with is just this amount here. Does that make sense?
Question, why is that x squared and not 2x?
Because it's 2x squared over 2. Remember, this is the same function as just now.
Oh, you just,
I just remembered that it was 2 cancelled.
got it.
Yeah? Does everyone see that that's what would happen? So if we just did it like this, just between 1 and negative 1, it's like, well, you're missing out on a good chunk of the area because this negative value is going to eat into this bit.
Wait, why?
Because whilst we appreciate that the area itself here is 4/3, our calculators or our calculation gave it as negative 4/3. And so if we for this one, if we just do between 1 and, okay, well, let's do it. Actually, let's stick the values between 1 and negative 1 into there. And I'll show you that they're different answers and hopefully we can appreciate a little bit more why. So if we were to stick 1 into here, we'd have 1 cubed over 3 minus 1 squared. Subtract negative 1 cubed over 3 minus negative 1 squared. I'm trying to write tiny. So it's 1/3 minus 1 minus negative 1/3 minus 1. So we've got our negative 1 to subtract negative 1, so that can be cancelled. So we've got 1/3 subtracting negative 1/3, so that gives us 2/3. So if we were to just do this calculation as is, we would think that the area was 2/3. Okay? Now, I'm trying to get you to appreciate, because this is underneath and this is above, it means that you're actually going to have to find these two areas separately. Ignore the sign of this one and then add the two together. Okay? So let's show you that then gives us a different answer. So if you have this kind of question, if they've given you a diagram, it's nice and straightforward because you can see that this value here of 0 is our middle point, if you like. Yeah, that's where it crosses the x-axis. So it means that we would have to do the integral between 0 and negative 1, then the integral between 1 and 0, and then add those two together, or add the absolute values of those together. You know what I mean by absolute value? Ignoring the sign.
Sure.
Bless your hearts, I'm not getting a lot of, yes, I'm understanding what you're talking about. So, x cubed over 3 minus x squared. I'm just going to write it because I know that's what it simplifies to be, yes? So we've got 0, negative 1. So 0 cubed over 3, subtract 0 squared, subtract negative 1 cubed over 3, subtract negative 1 squared. So this is 0, subtract negative 1/3 minus 1. 0, subtract negative 4/3. So that gives a positive 4/3 value. So we expected it to be positive because we knew it sat above the x-axis between the 0 and negative 1. So if I were to go back up to my diagram, I'll come back down in a second. So if I were to go back up to here, what I've just worked out there is this area here, and I found that to be 4/3. Okay? I'm now going to find area B. We'll do that in a different colour. So that's between 1 and 0. So questions like this, sometimes you have to establish your limits yourself. Okay, so you need to decide where is the graph above and where is the graph below. So here we've got x cubed over 3 minus x squared between 1 and 0. 1 cubed over 3 subtract 1 squared. I'm just going to write minus 0. Okay, you're right for that? So 0 then. So it's 1/3 subtract 1. So that's negative 2/3. As I said, we knew it was going to have a negative value because it was underneath the x-axis, but we would take our area as positive 2/3. So then what we would do is we would say that means that the area between those two values, so the total area, is 4/3 plus 2/3, which is 6/3, which is 2 whole ones. Now, obviously, that is a very different answer to the original one we had, but that was because our 4/3 had this 2/3 taken from it. Because you had a positive value plus a negative value, which meant it all went horribly wrong. Does that make sense? I know, I'm just going to shade. I'm just shading. I'm shading. So it looks pretty. So that bit was 2/3. So our total was 6/3. Does that make a bit more sense now, Katie?
Oh, yeah.
Yeah. What did I say at the back here? So an area is always positive. Definite integral is positive for areas above the x-axis and negative below. To find the area, we need to know where it crosses the x-axis between the boundaries. Okay, so that's essentially what we do. Now I'll give you some. We'll do some more practice on this, and then next lesson we'll talk about if they're between two curves. Okay, so sometimes we're going to find the area between two curves.